So, compound inequalities. So we already know about inequalities, right? We've talked about them. And let's just go over it a little bit what we've talked about. So I want everybody to find inequalities in your notes. We've talked about inequalities in your notes. Somebody find the date. Tell me the date that we started talking about it. What's the date in your notes? The 25th. Excellent. August 25th. So, when we talk about inequalities, what does the word inequality mean? Not equal, right? And so we got where two numbers or two values are being compared. They're not exactly the same. They're being compared. One may be greater than or less than the other. Are you all following me? So when we're talking about inequalities, we're giving a condition. So I'm going to give you a condition as an example. I'm going to say to you that every student in this school must be more than 12 years old. I'm going to say it again. Every student in this school must be more than. Their age must be greater than, more than 12 years old. Is that an equation or an inequality? Inequality. How many possibilities are there? A lot, right? It's not one exact answer. It's many possibilities, right? Give me an example of a possibility that fits that criteria. 14. Good. 19. 13. So do you agree that we have more than one possibility? Yes? So our constraint is, we got one constraint. And that one constraint is like a guardrail. It's like a boundary, right? We got one constraint. And that one constraint or that one condition is that the students must be older than what? 12. Give me an inequality that could represent that. First of all, what are we talking about? What are we talking about? What are we talking about that has to be over 12? The student got to be over 12? Be specific. The student got to be over what? 12 inches?
12 years old. 12 years old.
So what do we call 12 years old? What is that? An age, right? So we're talking about ages. So let's say A stands for the age, right, of the student. Everybody with me? Give me an inequality that I can write that would represent what I just said, which is that every student in this school must be over 12 years old. How do I write it? Yes.
A is greater than 12.
Clap it out for her. Excellent. Real claps. Thank you. Thank you. Thank you. Thank you. Excellent. The age of the students must be what? Greater than 12. Question, can it be 13?
Yes.
Can it be 15?
Yes.
Can it be 19?
Yes.
Can they be 12?
No.
Why not? Because it's greater. It has to be more than 12 years old. Does that make sense?
Yes.
How many conditions? What's the condition? Not how many possibilities. How many conditions? How many rules do they have to meet? One. What's the one rule? More than 12. So that's one condition. How many constraints? One. Condition, constraint, rule is one. Are y'all with me? Now, what if I say to you that the age of the students in this school must be more than 12, but also no more than 19? Watch what I just said. Yes. More than 12, but also no more than 19. How many constraints do we now have? Two. What's our two constraints?
12 and 19.
Got to be greater than 12. 12 is a constraint. And the other one is what? 19. Question. How do I write that? More than 12 and no more than 19. How do you write that? How do you write that? A is greater than 12, okay? And that same A has to be what?
Less than 19.
Do we agree with this? What's wrong? Less than or what? Equal to. Why do we put a or equal to for the 19? Because can they be 19?
Yes.
Yes, because I said no more than, which means could they actually be 19? Yes. Is everybody, good job, sir? Everybody following? So these are my two constraints. What is the difference between inequalities and compound inequalities? There's two what? There's two restrictions. There's two constraints. Is everybody following? There's two of them. Two constraints. Is everybody following me?
Yes.
Yes? Now watch this. How do I write this, Miss Stampley? Watch this. I'm going to put an A in the middle. Doing good. Stay. What's my minimum? 12. What's my maximum? 19. Look at this. All the ages have to be between what? 12 and what? 19. Does that make sense? Yes? So I'm going to put a sign here like this. Looks just like that one, right? What sign am I going to put here?
Greatest.
I'm going to do this sign.
No.
No.
Less. Wait, no.
No.
Think about it.
Wait. No.
Yes. No. You can flip the sign. Like the age and the minimum.
Watch this. What does this say? They can be any age, what? This says A is greater than 12. So if I write 12 first, you flip it. If A is greater than 12, then 12 must be what? Less than A. So what is the sign that we would put here?
Less than.
It would be less than. Now I'm gonna let you sit on that for a minute because some people are looking crazy in the face. Like I said, but what you talking about? But I'm gonna show you. Let me give you this example first. Oh, erase it. Watch this. Do you agree that 4 is less than 5?
Yes.
Yes? Stay with me. So then if I were to write this, would it still be a less than sign? No. If 4 is less than 5, then that means 5 is what? Greater than 4. So if A is greater than 12, then that means 12 is less than A. And here's the other trick that you can just remember. Once you plug that sign in, all the signs should be going the same direction. That's it. Because this falls between these two. Are you with me? It's greater than this and less than this. Does that make sense? Does everybody see that? All right, now let's go back to what we did the other day. The other day, we talked about things being inclusive and exclusive. Y'all remember that? Yes? Here, inclusive or exclusive? Find the words. What does it mean? Inclusive and exclusive. What is this one? Is it inclusive or exclusive? Find your words. Exclusive. Why exclusive? It's going to be an open circle. Is 12 a possibility? Can a kid be 12 years old? No. So watch this. Let's show what that looks like on a number line. Remember, because there's so many possibilities that we can't list them all. So let's put them all here, right? So do what I'm doing. I'm going to put a 12 in the middle. Now my question is, do I put an open circle or a closed circle? Which one? Open circle. Open circle means it's not included. I'm not including 12 as a possibility, right? Now, what does it say? It says any number. What's the symbol? Which way is it facing? It's looking like this. Going to the right. So what is it? Greater than. Where's greater? To the left or to the right? To the right. What's all the way out here to the right where you can't go no further? Infinity. What's all the way out here to the left where you can't go any further? What? Negative infinity. So, if I shade to the right, then any number from 12 to the right is going to be a solution. Are y'all with me?
Yes.
One constraint, inequality. Lady, no. I'm trying not to make you stand up. Get your head off your hand. Participate. Now watch this. Let's write this in interval notation. For interval notation, don't we need a minimum and a maximum? Look at your notes from the 25th. Let's go. What's my minimum? What's the lowest possibility? 12. What's my maximum?
19.
Not in this.
Oh, infinity.
It's infinity in this one. Are y'all following? All right. You told me it was inclusive or exclusive? Exclusive. So am I going to use a parenthesis or a bracket for the 12? Parenthesis. When do we use brackets? When it is what? Inclusive. That means it includes that value, right? Now let's look at infinity. What am I going to put on infinity? Am I putting a parenthesis or a bracket? Y'all don't stare at me. It ain't going to just fall out the sky and go into y'all brain. Y'all need to look at y'all notes and figure it out. What is it going to be? Why?
Because the infinity is included.
How you know it's not included?
I mean, we're calculating.
I shaded that way. Why it's not included?
No, it is included. It goes all the way up. It's a bracket.
Because what? Infinity is not a what? Can you take, if somebody asks you what is that value? Can you give me a value for infinity? You can't plug that into nothing. You can't check that, plug it in and check your solution. It is not a real number. It just gives you a direction and tell you how far you can go. But it's not a real number. So we never use an inclusive sign. We never use a closed circle. We never use a bracket for infinity because it's not a real number. What are we going to use? Parentheses, not included. It's any number to infinity, but that's not a real, that's like non-stop. If I tell you one more time, this time don't sit back down. Hey, up. And don't sit back down. Next time you let me tell you when. Okay. Do we understand this part? Yes? So this is how we represent it on the number line, and this is how we represent it in interval notation. Y'all with me? Yes, baby. While I'm teaching. And you can't go anyway, baby, because there's only 7 minutes left. Okay, you can't go to the last 15. We good here? Yes? All right, now let's go. What about here? Let's talk about this one. What are my two constraints? 12 and 19. Y'all ain't got to whisper, talk out loud. 12 and what? 19. Right? Now, let's talk about this 12. Open circle or closed circle? Open. Why is it open? Because it's excluded. Is the 12 included as a possibility? If we would have seen this, then it would have been what? Closed circle. But we don't see that. So that's not closed circle. Are y'all with me? What about 19? Open circle or closed circle? Closed circle. Because 19 is included. Everybody follow? Yes? Now let's talk about what this is saying. Pay attention to what it says. This is very important. It says A is what? Greater than 12. So that means A is starting here and going this direction. Y'all follow? Now, it says this one, at the same time, it is what? It starts at 19, and which way does it go? Left. Anything less, right?
Yeah.
So this is covering here, and this is covering here. What do they have in common? This is saying everything from here this way. This says everything from here this way. What do they have in common? Is there anything, where are the numbers that are greater than 12 and at the same time less than 19? They're in the middle. So where are my solutions to this compound inequality? They're in the middle. They are here. Here's where my solutions are. Between this and this, including this. Does that make sense? Yes? Now, why is 20 not a solution?
Because it's 19 is over 19.
But does it not meet this condition? Is it greater than 12?
Yes.
Is 20 greater than 12?
Yes.
So shouldn't it be a solution?
No.
It's only a solution if it was a regular inequality. It's not a solution if it's a compound inequality, because this says it has to meet both conditions. Not only does it have to be greater than 12, but it also must be less than or equal to 19. So 20 would be out the way. Are y'all following me? What about 6?
Nah.
Why?
Because it got two constraints.
It got 2 restrictions and it only meets 1. Which one does it meet?
The 9.
19. It's less than 19. But it's not greater than 12, so it doesn't meet the condition. Are you guys with me?
Yeah.
So with compound inequalities, it has to meet both conditions. Are you all following?
Yeah.
Is everybody following? Yes? So what are going to be the solutions to this particular problem? What's my solution? Any number between what?
13, 14,
12 and what? 19, including 19. So the way we say that is 12 to 19 inclusive. Are y'all following me?
Yeah.
Yes? Why am I saying inclusive when I get to 19?
Because it's inclusive.
19 counts too. 19 is included. Does that make sense? Yes? All right, now let's write this using our interval notation. Y'all ready? Interval notation, we need a minimum and a what? Maximum. What's my minimum? 12. What's my maximum? In this case, it's 19. Now, is the 12 included or excluded? Excluded. So what am I going to use? Parenthesis or bracket? Parenthesis. Very good. 19. Is it included or excluded? Included. So what am I going to use? Parenthesis or bracket? A bracket. And that's how we show that. That's it. So if you were to see this somewhere, you would be like, oh, my minimum is 12, my maximum is 19, but 19 is included, 12 is not. See how we read that?
Yeah.
Okay? Everybody good here?
Yeah.
Any questions? No. All right. So what are we going to do? We are going to be moving on to do problems that have to do with compound inequalities, right? And we're going to find the solutions to them. It's very simple. And then we're going to graph those solutions and then write them in interval notation, right? So I want to give y'all one problem that I want to try with you real quick, and then we'll be done. Let's look at put this on your paper. Put compound. Draw your little squiggly. Put compound inequalities, and then I want you to write next to it A10. And we're going to start with number 7 real quick. I'm going to do number 7 with you, and then we're going to move on. Number 7 says -5, write what I'm writing, is less than or equal to 2x minus 1 is less than 7. How do you know that this is a compound inequality? It got 2 conditions. What's your 2 constraints? -5 and what? And 7. Are y'all with me?
Yeah.
This is called an and. It's an and. It is an and condition. It's an and inequality. Are y'all with me? How do I know? Because it has to meet both conditions. This has to be greater than -5 and at the same time less than 7. Are y'all with me?
Yeah.
Now watch how we solve this. This is 2 separate things. Y'all see the 2? What's the first rule? -5 is less than or equal to 2x minus 1. Y'all see that? What's the second rule? 2x minus 1 is less than 7. Do you see the 2 separate rules? Do you see how they're built into one? Yes? So what are we doing? We're really just solving both of these and finding the solution. That's it. Are y'all with me? Let's solve this. What would I do? I'll draw my squiggly. Just focus on this. What am I solving for? What are we always solving for? X, the variable. X. What's around X that I want to get rid of? -1 and 2. Which one I'm going to get rid of first? -1. How am I going to get rid of a -1? Add 1. So I'm going to add 1 to both sides. Work with me. These cancel out. Our goal is to get this X by itself. So now I got -5 plus 1. What we get?
6.
Y'all got calculators. I don't. Don't give me no wrong answer with no computations. 5 negatives and 1 positive. You're going to cancel out something and end up with what? -4. So this is -4, not 6. It's less than or equal to 2x. Are we done?
No.
What do we still need to do?
Divide.
How are we going to do that?
Divide.
Divide. We're going to divide both sides by what we're trying to get rid of. Those going to cancel out. What do I have left over here? Negative 2 is less than or equal to x. Does everybody see that? Yes? Clean it up. Give it to me using metric property. What should it say? X is less than or equal to what? Negative 2. If no. That's not gonna work. Why? Negative 2 is less than x. So that means x has to be what? Greater than or equal to what? Negative 2. Do we see that? Yes? Now let's do this side. I'm gonna draw my squiggly. What do I need to get rid of? What's around my x that I want to get rid of? 2 and negative 1. Which one first? Negative 1. I'm going to do what? Add 1 on both sides. So now we got 2x is less than 8. Now what?
Divide.
Divide both sides by
2.
2. So now you're going to have what? X is less than 4. So what's your first condition? It must be greater than what? Negative 2. And it must also be what? Less than what?
4.
The more y'all don't talk to me, the more I'm going to keep talking. It has to be greater than negative 2, and at the same time, it must be what? Less than 4. So what is it going to be? It's going to be between negative 2 and what?
4.
Positive 4. Open circle or closed circle?
Close.
Closed. Open circle or closed circle? Open. And where am I shading? What do they have in common? I need it to be greater than negative 2 and at the same time less than 4. So where are we shading? In the middle. Right here. All the solutions fall right in the middle. Does that make sense? Yes? Pack up. Can you stop it for me, baby?